determine whether the following lines are equal, parallel but not equal, skew or intersecting. Okay, so we have L1. Let me write nicely here L1 given in parametric form. So x equals 2t, 0 plus 2t, y equals 1 minus 1t, and g equals 3 minus 3t. So from this we can read the direction vector v. Our first line, let's say v1, which is 2, negative 1, negative 3. And for L2, we can clearly see the direction vector 4, 2 and 6. But be careful, this is not given in nice form. So 2 minus x. So what we have to do, t is already used. Let's say this equals yes, another real number, and solve each. Okay, then we have 2 minus x over 4 equals yes, 4s. So 2 minus x equals 4s. Move over x, so x equals 2 minus 4s. So x equals 2 minus 4s. Similarly, y equals negative 2 plus 2s, and g equals 1 plus 6s. Okay, and the direction vector for this line is negative 4, 2, 6. Or you could have changed 2 minus x to x minus 2. That would give negative 4, and that's what we have here. Look at these two direction vectors. Okay, clearly v2 is just negative 2 times the first vector, right? Because if we multiply this by negative 2 times 2, negative 4, and we get this. Okay, since that means v2 and v1 and v2 are parallel, that means the lines are parallel. Okay, since v2 is just negative 2 times v1, okay, the direction vectors are parallel. In turn, the lines are parallel, so the given lines are parallel. Now they can be the same line. Okay, so we need to check if they are the same line. Sometimes they are parallel, and now they are parallel. Now we need to check if they are equal or not equal. So the idea is we want to solve these equations to see if they have a common point. Okay, if we can find a common point, just one common point in these two lines, then we have infinitely many common points. I mean, they will be the same. So what we do is, let's set x and x equal to check if the lines or if they have a common point, say xyz. Okay, we set them equal. So x equals 0 plus 2t, that's 2t, equals x equals 2 minus 4s. Let's solve for one variable, maybe t, divide by 2, so t equals 1 minus 2s. And if we set the second equal, y equals y here, then we have, plug in this t in the second. Okay, 1 minus 1t equals minus 2 plus 2s. We're gonna plug this t value here. That implies from t 1 minus t. T is 1 minus 2s equals negative 2 plus 2s. Okay, in this way we will be able to find s value. Then we go back here, or t value, whatever you like, then go back here, plug in that, you get 1 point, and plug in t here. If we get the same point, then the lines are equal. Okay, let's see here what we're gonna get. So distribute negative, so 1 minus 1 cancel, negative 2s equals negative 2 plus 2s, subtract 2s from both sides, so 0 equals negative 2. That's false. That means we don't have a common point, okay, in these two lines, so they are just parallel, not equal. So the lines are parallel but not equal. Okay, I graphed these two lines using GeoGebra software, and it was like this. Let me show you the lines. They are parallel, they are not the same. Yeah, here is the case. Okay, these are the two lines and they are not the same, but we don't know how to graph using hand. Okay, final.